Hello. So our today's topic is periodic table. It will contain symbols, organization of elements, classification of elements, and trends in atomic properties. Our learning objectives today is to understand element symbols, to explain organization of elements, classify the elements, and to analyze periodic trends. We will learn all these things today. So symbols of elements, how elements are symbolized. One or two letter notations are used. First letter always being capital and second one is small. These letters are derived from English or Latin names, not only from the spelling but also from the pronunciation. So some examples are shown here. More we will learn with the go. So organization of elements. This is the modern periodic table. So many things are there to note: the colors, the symbols, the numbers, the blocks. Let us go through them one after another. So first we will take a block. We can see some letters and some numbers. Let us see the letters first. Fe. This is the symbol. Symbol of what? Iron. The name is iron. Name of the element is iron. Why Fe? When it is Iron? Because it is derived from its Latin name, ferrum. Atomic mass is given in the top left corner, 55.845. Atomic number on the top right corner, 26. First ionization energy is given in the leftmost corner, top corner, but second from the top, 762.5, and 1.83, the second from the top on the right side, that is 1.83, it is the electronegativity. What are these? We will learn as we are moving through the slides. And electronic configuration is represented at the bottommost left corner, and on the right side there are number of figures with plus or minus sign. These are the oxidation states exhibited by iron. So the bold ones, +3 and +2, these are the most common oxidation states, whereas the others are exhibited by iron at some or other time. But +3 and +2, these are the most common ones. So next we will learn the color codes. These are the color codes like alkali metals, orange, alkaline metals, orange but little faded ones, and so on and so forth. The radioactive elements will be having their masses in parentheses on the table. Let us see some examples. So you can see here, some of them are having their masses on, for example, let us see uranium. The mass is given in parentheses. Then these blocks. These blocks represent the outermost orbital of the element which contains electron. So S block, D block, P block, F block. Then this table is at the bottom of the table, separate table. It is containing two rows. So first row, the topmost one, contains lanthanides element, and bottom one actinides. So if you see the periodic table, then after 56, after barium, you can see 71 atomic number. So 56 to 71 is there at the bottom, 57 to 70. It starts with lanthanides, so the series is named as lanthanides. And then next one, 88 to radium to 103. So 89 to 102. These are known as actinides based on the name of the first element in this series. These are known as inner transition metals. And what's this? This is the diagonally placed in between metals and non-metals. They are metalloids. So you can see in the periodic table this diagonal separation. And then classification of elements. Already we have learned metals, non-metals and metalloids. Metals are conductive of both heat and electricity. They are malleable, ductile, that is, they can be hammered down to make thin sheets, and they can be drawn into thin wire. Non-metals, they are poor conductors of both heat and electricity, and they are neither malleable nor ductile. Metalloids, they have intermediate properties between metals and non-metals. So you can see the metals in yellow, non-metals in blue, and metalloids in pink. And the properties are given below. Metals, shiny, highest degree of metallic behavior, thermal conductivity good, electrical conductivity good, density high, melting point high, usually solids at room temperature. Only one exception is there. Can you name them? Name it, sorry. Can you name it? Yes, mercury. And electronegativity very low. Metals are electropositive. Then non-metals, obviously in between non-metals, obviously it's just opposite of the metals, like dull in appearance, lowest or no degree of metallic character, thermal conductivity, electrical conductivity, both are very poor, density low, melting point low. At room temperature, they are either solids or gases. Electronegativity very high, and one exception is here again. At room temperature, one non-metal is liquid, that is bromine. And metalloids in between metals and non-metals, they may be shiny or dull. They have very low degree of metallic behavior, but they have some metallic behavior. Thermal and electrical conductivity, they are semiconductors. Density fairly low. Melting point between metals and non-metals. At room temperature, usually solids. Electronegativity between metals and non-metals. These are the properties for metals. Then we are going for the atomic properties. Atomic radius. This is the distance from nucleus to outermost shell. This decreases across a period, increases down a group. So you can answer one hot question, high order thinking skill question here. Arrange sodium, magnesium and aluminium in increasing atomic radius with justification. It's task for you. Then atomic radius trend is shown here. Already I explained this. Ionization energy. This is the energy required to remove outermost electron. Increases across a period, decreases down a group. So how much energy is needed to take away the very first electron from an atom? So another hot question, which has higher ionization energy, oxygen or sulfur? Obviously, this is not the question. The main question is explain your answer. So ionization energy trends. Metallic character, this is defined as tendency to lose electrons. Decreases across a period, increases down a group. Properties we have discussed already. The hot question for this slide is, why is sodium more metallic than magnesium, though both are in period 3? Metallic character trait. Electronegativity. Ability to attract electrons in a bond. It increases across a period, decreases down a group. And the hot question, arrange carbon, nitrogen, oxygen and fluorine in increasing order of electronegativity. Electronegative character means, let me explain a little bit more. That is, when two atoms are bonded together, covalent bond, then they share one electron each with each other. That means they both both the partners, they own the electron pairs similarly. They should own them similarly. But if one of them is having higher electronegativity, then that atom will be having, or that nucleus will be having more power over the shared electron pair. That means electron pair will remain more close to this nucleus more often than the other one. So thereby developing a negative charge, transient negative charge near the electronegative nucleus and transient positive charge near the other one. So there will be a polarity in the bond. We will discuss more about this when we will learn dipole interaction or polar molecules. Okay. So the HOTS questions: which has larger atomic radius? Arrange F fluorine, oxygen, and nitrogen in increasing electronegativity order. Predict ionization energy. Train down group 1 with reasoning. And compare atomic radius of sodium and chloride. The solution is given here. Both are in periodic 3, but radius decreases left to right. Answer: sodium is greater than chlorine. These were your tasks. So by this time, if you have not completed, you can cheat yourself by looking at the answers. Then this is the next one. Arrange lithium, sodium, potassium in increasing ionization energy. Same group. Ionization energy decreases down the group. This is the hint. Arrange carbon, nitrogen, oxygen in increasing electronegativity. Same period. Electronegativity increases from left to right. So this is the answer. Thank you all. See you in our next video. Keep studying, keep learning. Bye.